All right, this is 8.2 cosine law. Yesterday we learned about the sine law, so I'm just going to quickly review that with you. Sine law, the markers are poor, garbage. Sine law, we put the side length on top. That was one way to use this law. And we determined that these ratios, the ratio that includes the side length over the sine of the opposite angle, we're all equal. We're all equal ratios. So if we look at a triangle and we name it side A, side B, side C, it means we have vertex A, vertex B, vertex C. Again, capital letters for vertices, lowercase letter for side lengths. Side length is named according to its opposite vertex. So you have C across from C, B across from B, and I think you get it. Well, we now know that the ratio between the side length B and the sine of angle B is equal to the ratio of any other pair of side length and angle. Okay, so we're talking about opposite information when we're using sine law. So for example, if I had side length A and angle A, I could complete one of these ratios, which means that if I had, let's say I had angle B, I could find out what side length B is simply by using two pieces of the sine law. Okay, if I have one missing piece of information out of the four, then I can use the sine law and basic algebra skills to solve for side length B. Okay, and we can think about that in other ways as well. Let's say I had angle A and side length A, and let's say I had side length C. Could I solve for angle C?
Yes.
Yes, I have opposite information, and I have another piece of my ratio puzzle. So in this case, I would be using A over sine A is equal to C over sine C, and I would solve for angle C. Now, question, would I use this form of the sine law for that?
No.
No, what would I do?
You would flip them around.
Yeah, I'd invert each of my ratios, and I'd have the same thing. So I'd have sine A over A is equal to sine C over C. That would allow me to solve for the sine of C, take the inverse sine of both sides, and away we go. Okay, what about this situation? What if I have angle C, angle A, and side length B? I should be using check mark. Could I solve for let's say this. Could I solve for angle or side length C?
Yes.
Who says no? Why not?
Because you don't have. Oh wait, do you know C, the big C?
I know big C, but I don't know little c.
Oh.
I know big A, but I don't know little a. And I know little b, but I don't know big B.
No, you can't.
I do not have opposite information, so I can't immediately solve this. But look what I do have. I have one angle, two angles, which means that I actually do have angle B. So I would first use my sum of interior angles to get angle B. Then I could use this completed ratio, B over sine B. And then I could solve for side length C. Okay? Now, I'm going to draw one more situation. And it's there for you in your notebook already. What if you had the following information? You know this side length is 5. You know this angle is 78 degrees. And you know this side length is 8. Can I solve this triangle? Can I use sine law to solve this triangle? I have 3 pieces of information. Do I have any opposite information? No, I don't have this opposite angle. I don't have this opposite side, and I don't have this opposite angle. So I cannot complete any of these ratios, which means I cannot use sine law, which means I need another law, the cosine law. Okay? Yesterday we learned that the sine law could be derived from taking any acute triangle, splitting it into a right triangle, and then getting two different equations. So you have two right triangles, and you'd use primary trig ratios. You'd use SOHCAHTOA for this triangle and this triangle to come up with two expressions for h, okay? And then we set them equal to it, and we figured out that, oh, that means this is true, and we can use this in any acute triangle, okay? We did that in 8.1, so if you want to learn that, you can go back and watch that again. We're going to do something similar for 8.2. We're going to find out how the sine law is derived. So where does it come from? Why does it work?
Does anyone remember?
Oh, yes.
All right, we're going to derive the cosine law on that page in your notebook. You have a drawing already. So let me get that. That is just an acute triangle, ABC. And they've drawn us a line down the middle. That's the altitude. It meets at a right angle. We're going to call that H. And then we're going to name this side length, the base of triangle ADC. We're going to name that X, which is there for you, which means that DB is C minus X. C being the whole length of the original triangle, the base of the original triangle. So we've split triangle ABC into two smaller right angle triangles, and we've named all our sides. So in order to do this, we're first going to look at triangle ADC. ADC, so we're looking at this smaller triangle on the left-hand side. And we're just going to think about Pythagorean Theorem for a second. Which side length here is the hypotenuse? B, H, or X?
B.
B is the hypotenuse. So thinking from Pythagorean Theorem, we know, what do we know? We know B squared equals X squared plus H squared. We also know the cosine ratio from SOHCAHTOA. So cosine from SOHCAHTOA, the cosine ratio, SOHCA, adjacent over hypotenuse. So we're going to look at this from angle A. So we're going to have the cosine of A is equal to adjacent over hypotenuse is equal to X over B. Those are two things that we know that we're going to use. And I'm going to just come up with an expression for X using this, okay? So how do I get an expression for X? I'm just going to multiply both sides by B. That's going to give me X equals B times the cosine of A. Okay, again, this is one of those things that you're not going to obviously see what we're doing or why we're doing it right off the bat. Just proving that the cosine law works and that it comes from splitting this thing into two right triangles and developing a rule for any acute triangle and the relationship between its sides and angles, which we'll explain in more detail as we go on. Okay, so we're going to look at the next triangle now. So from triangle BDC, that's the right-hand side, the right triangle on the right-hand side. What information are we going to get from that? Well, we're going to look at the Pythagorean Theorem again. In this case, the hypotenuse is A. So we've got A squared. And it's going to equal H squared plus, and the side length of the base here is C minus X. So I need to make sure I put that in brackets. That's the side length of the base. And that's going to be squared. So I have the sum of the squares of the legs is equal to the square of the hypotenuse. But we know that these two triangles share H. So H from the first triangle and H from the second triangle are going to be the same. And X, the value of X from the first triangle is going to be the same as the value of X right here. Okay? So what does that mean that we can do? Well, let's, I'm skipping ahead a little bit. Let's first expand this and then we'll rearrange and we'll gather our terms, okay? Then we're going to sub in what we know about x right there. So here we go. First expanding the right-hand side, a squared stays the same, h squared stays the same. The expansion of this, you should know how to do a binomial squared, but the pattern is a squared minus 2ab plus b squared. Do you remember that?
Oh, yeah.
Okay, so that's my pattern here, where a is c and b is x. So what I have here is c squared minus 2cx plus x squared.
Why is that?
Okay, I'm just going to rearrange this on my right-hand side. I'm going to go with x squared plus h squared plus c squared minus 2cx. Okay, I haven't changed it there. I just rearranged it. So it's a little bit easier for me to work with. And now I know what this x is equal to. So right now we're still using this height in our triangle. When we're all done, we're not going to be using that. We're just going to have it, we're not going to have an h here. We're just going to have it in terms of the side lengths of the original triangle, ABC and ABC. Does that make sense? So I don't want to be using h and I don't want to be using x. The goal is to not have those and just have a relationship for ABC and ABC.
There is no B.
Yeah. Anyway, hopefully that makes a little bit of sense. We're going to carry on. And here we go. We've rearranged the terms, and now I know a couple of things. I'm going to substitute. We already know that b squared is equal to x squared plus h squared. Well, what do you see here? X squared plus h squared. So I can substitute b squared for those terms. I also have an x here, and I know that x is b times the cosine of a. So let's see what happens when we do that. We're going to put in b squared instead of x squared plus h squared. We know that they're equal. We still have plus c squared, and then we have minus 2 times c. That's still right here. And then x is b times the cosine of a.
Did you switch out x and h for b and c?
Nope, just this for this, because it's right here. B squared is equal to those two together. So we put b squared in. Over here, x is equal to b times the cosine of a. I'm going to rearrange this just so that these two, and you could, maybe in this step, I'll just leave it like that. That's kind of what it looks like, right? We put x in to cx. Well, this is x. I'm going to rearrange this right-hand side. It's going to be b squared plus c squared minus 2. And because this is multiplication, I can order these however I want. So I'm going to go 2 times b times c times the cosine of a. And now we have a formula. We have an equation that relates the 3 side lengths in this triangle and 1 angle in this triangle. Okay, this is the cosine law. There are other ways to write it. We could have done a different altitude in this triangle. We could have done the altitude from A or the altitude from B. Okay, and then we would have come up with different forms of this equation. We would have maybe come up with an equation in terms of isolating b squared. If you are looking for the side length b, then you have a squared plus c squared minus 2ac times the cosine of capital B. An easier way to remember it, what does this kind of look like? This b squared equals a squared plus c squared. Kind of looks like Pythagorean Theorem, okay? And actually, if you did this with a 90-degree angle here, you would just get you would get the Pythagorean theorem. Anyway, because the cosine of 90 is 0. You don't know that yet, but that's what it is. So this whole thing would be 0, and you'd be left with just the Pythagorean theorem. So actually, this is the Pythagorean theorem, or rather, the Pythagorean theorem is this. Okay, so what's an easy way to remember this? Here's what you need to know. If you're looking for a side length, this is a good way to set it up. And when you're looking for a side length, you need to know its opposite angle. So the side length goes way over here on the left, squared, and its opposite angle goes all the way on the far side. Okay, capital B for the angle, lowercase b for the side length. Now what else is in here? Well, you have an a squared plus c squared minus 2ac. This is just the other two legs of the triangle. And question, does it matter what order I put them in? Which side length I call A and which side length I call C?
No.
It doesn't, because they're both getting squared and then added together. What about here? Does it matter if I write 2CA or 2AC?
No.
Doesn't matter. Multiplication is commutative, just like addition. So all you need to remember is that your unknown side length is here, its opposite angle is here, and the other two side lengths fill in the rest of the information. Okay? Go ahead and try to write the version of this cosine law that would solve for the side length C. Go ahead and try to write the version that would solve for the side length C, and then double check with me. Okay? Hopefully that went well for you. You simply have the side length that you're looking for. You're going to know the angle in between. I'll explain what that means in a second. And then you have your other two legs that you're going to know. So again, we started with the idea of how do you solve this triangle? Okay? What you have here is you have two side lengths and the contained angle. That's what it's called. It's contained, right, by the two side lengths that you know. So if you have two side lengths and the contained angle, you now know how to solve for this third side length. Okay? And if you have this third side length, how do you think you could solve the rest of the triangle?
By filling it in.
You now have opposite information, which means you can use the sine law. Okay? So don't, you're getting this information in chunks in different lessons, but it all works together. It all goes hand in hand. Again, this was just to show you that the cosine law is a real thing, and it can be derived from any acute triangle, drawing a right angle triangle, thinking about Pythagorean theorem, and thinking about your primary trig laws. Okay? I'm going to write a little statement that goes with cosine law. Cosine law. The relationship between the cosine of an angle and the lengths of the three sides in an acute triangle. What does that mean? So the relationship, so how they relate to one another, between the cosine of an angle. That's why it's called the cosine law. And that's right here. See that? Here's the cosine of A, cosine of B, cosine of C. So the cosine of an angle and the lengths of the three sides. So all three sides are involved in our calculation. A, B, and C. Okay? So it takes one angle and the three side lengths, puts them in a relationship. That means that we can use it for any angle when we have the three side lengths, okay? Or you can use it to find the side length when you have the other two side lengths and the opposite angle, okay? Or the contained angle. And we're going to get using it so that we can solidify our learning. Okay, heading into example 1, we're going to find a side length using cosine law. So we've got this beautiful little diagram here with a lighthouse and a sailboat and what looks like a rock, a hazard. Okay, I'm going to draw a simplified diagram. We've got a boat sailing north through the strait. Through one particularly narrow section, a lighthouse marks the western shoreline, while a buoy indicates a rock hazard directly east of the lighthouse, just like shown. What is the width of this section of the strait to the nearest tenth of a kilometer? So we've got a rock, R, we've got a sailboat, boat, B, and we've got H. I'm not sure why we're using the letter H, but we are.
You could use L.
You could use L for lighthouse. H for house. There you go. Lighthouse, sailboat. Not sure. Terrible choice, but that's what we're going to do. So we know this. We know that the hazard is 4.5 kilometers away from us. And we know the lighthouse is 4.2 kilometers away from us. We know that from the boat, the angle in between the lighthouse and the rock is 26 degrees. Hey, this looks a lot like a right angle triangle. Shouldn't I just use SOHCAHTOA?
No,
Why not?
because we don't know it's a right.
You don't know it's a right angle triangle unless they put a little square in the corner. You cannot assume things like that based on a diagram. All right. So what are we trying to figure out here? Trying to figure out the width of the strait. So I don't get to choose what to name it. The opposite vertex is named B, so the side length is going to be B. All right, that's what we're looking for. Now, look at what we're given. We're given two side lengths and the contained angle. Okay? In acronym world, that's called SAS. We are given SAS. That's two side lengths and the contained angle. Two side lengths and the contained angle. Let's just say note. Useless marker. Gone. Okay, so since we have that, we can use cosine law. Right away, I'm going to look at it again. We said it's not a right angle triangle. Can't use Pythagorean theorem. Can't use sine law. Sorry, can't use primary trig ratios. So then I'm going to look and see, can I use the sine law? No, I don't have opposite information, and I don't have two angles. If I had two angles, I could get opposite information. So I have to resort to the cosine law. And I'm looking for side length B, so I'm going to write it with respect to B squared here. I'm going to isolate B on the one side, which means that my other side lengths are R, so R squared, plus H squared, minus 2 times R times H, times the cosine of capital B. Good with that? That's just the cosine law, general form, using the letters that are in my diagram. So, fill in what we know. We know every other piece of information here on the right side. R is 4.2. Make sure I square it. H is 4.5. Make sure I square it. Then I have 2 times 4.2 times 4.5 times the cosine of a 26-degree angle. And now that whole right side, I could punch into my calculator in one go. Okay? 4.2 squared plus 4.5 squared minus, and now I'm not actually sure what my calculator is going to do here. So I usually hit enter at this point, and then I just do minus the next part. But I'm going to go ahead and just do a big bracket here. I'm going to put this whole next piece in brackets. 2 times 4.2 times 4.5 cosine 26, close that bracket, close that bracket. Okay, I can go through that a little more slowly with you if you need it. But what I end up there is that b squared equals 3.9155, and I'm just going to put dot, dot, dot. Okay, that tells my teacher that I'm not rounding it. I'm going to store that information in my calculator
About 3.751.
when I do my next step. Okay, so I'm going to store that in my calculator in order to square root both sides. And when I do that, I'm just going to hit second function, square root, second function, answer. That's going to bring in my stored solution from last time. And I get approximately 1.979. Double check back. It asks me to do to the nearest tenth of a kilometer. So this is actually going to round up.
It's B, not B
Sorry,
squared.
it's b, not b
Let's
squared.
go.
Caught a split second before me.
Ah,
Okay, this is, I'm going to round this up to 2 kilometers, okay? So the width of this section of the straight is approximately 2 kilometers. Okay, and because they asked for it to the nearest tenth, you might write 2.0 kilometers. What did we do? We just identified that we would need to use cosine law because we had side, angle, side. We had 2 sides in a contained angle. We don't have a right angle triangle. And so we subbed in what we know and square root both sides, and we popped out with 2 kilometers. Okay, in example 2, we're going to solve a whole triangle. It's triangle EDF or triangle DEF, and they don't give us a diagram, so we need to draw it ourselves. Now, we've done this before. We know how to do it. What's going to be my strategy, you think, for drawing a triangle that I don't know what it looks like?
you are going to draw a horizontal line.
I'm going to draw a horizontal line. I don't care how long it is. Okay, that line's going to be way too long. I'm going to cross some of it off when I'm done. Then what am I going to do?
You're going to take one of the angles and draw that.
Yeah, they give me angle E. See that? They give you side length D, side length F, and angle E. So I'm going to do my best to draw a 64-degree angle. Probably looks something like that. When you're doing this, you're always going to end up drawing above. I just find it easier. You could, of course, draw below, but you want to leave some space. I'm not sure if I left myself enough space here, but that's what I've got. I've got 64 degrees, and I know this is angle E. Now, if this is angle E, then that means these sides are D and F, right? Because side E is going to be somewhere over here. I don't know if it's going to go this way or what it's going to really look like. But these are going to be D and F, and it doesn't matter at all which one I put where, okay? So here's what we're going to do. We're just going to go ahead and write that this is 4.9 centimeters. That means this is side length D, which means angle D is somewhere up here. And this side length here is going to be side length F, which is 6.2 centimeters. And now all I have to do is kind of look at this and say, okay, you could easily use a ruler. You could easily use a ruler to do this and get an almost exact diagram, okay? But this one, this side length is about 5 centimeters. This one's about 6, so this one should be a little bit longer than this one. So let's just say it looks like that. Are we content with that? Again, doesn't have to be perfect. Erase my extra stuff. Label your vertices. And my one missing side length is E. And it's asking me to solve this triangle. What does it mean to solve?
Find all angles and all sides.
Very good. Find all the missing information, the angles that are missing and the side lengths that are missing. And again, I want to go through, is it a right angle triangle? No. Can I use sine law?
Yeah, no.
No, I don't have opposite information, and I can't use the sum of interior angles to get opposite information. So I have to go for cosine law. Now, we only know how to use cosine law for side lengths so far,
Yes.
which is fine. But look at the information that we have, right? We have two side lengths and the contained angle. So we have SAS, okay? Since we are given SAS, comma, use cosine law. All right, so I'm going to set this up solving for E. You go ahead and write the general form of the cosine law, solving for E, and then check the board to see how you did. Should look like this. And I'm ready to plug in the information that I know. D is 4.9. And again, it doesn't even matter if I do D first or F first, as long as I got the two other sides, the square of the two other sides added up. 6.2 squared, and then in here, 2df, 2 times 4.9 times 6.2. Again, doesn't matter what order those are in. And then the cosine of the contained angle, which is the cosine of 64 degrees. And I can punch this in my calculator. I'm going to just go ahead and not do that. I'm going to get it out of the book so that we can move along. So E squared is 35.814 dot 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 dot. Again, I'm doing that just to show my teacher that I'm not actually going to use this rounded answer. I'm going to use what's stored in my calculator. Take the square root of both sides. I get that E is approximately 6.0. I'm rounding to 1 decimal place because that's what they did in the diagram. So if a diagram gives you rounded to 1 decimal place, then just keep rounding to 1 decimal place. If they give you whole numbers, you could still round to 1 decimal place. It's a good idea, especially if you're going to use this information now in the rest of the problem, which we are going to do. So now that I know that E equals 6 centimeters, how am I going to solve for the other missing pieces?
You were going to use the other one, the SOHCAHTOA.
SOHCAHTOA is only for a right triangle.
Oh, we can use
yeah.
the sign. We can use
Yeah, now that I have opposite information, use sine law. All right, so let's say, well, I know I'm going to be using E and E because that's my completed ratio. And let's just solve for angle D first, okay? We'll solve for angle D first. Because I'm solving for an angle, I'm going to put the sine of D on the top. And I'm going to write the general form that I'm going to be using. That's going to be over side length D. And my completed ratio is sine E over lowercase e. Ready to plug in what I know. Sine of D, that's what I don't know. I'm trying to figure it out. Side length D is 4.9 over, so I got in the numerator over here, the sine of 64 over the side length that we just found out, 6. How am I going to solve for the sine of D? I'm going to multiply both sides by 4.9. Then I'm going to take the inverse sine of both sides. So look at what it ends up looking like. I'm going to do 2 steps in one. D is going to be equal to the inverse sine of 4.9 times the sine of 64 over 6. Okay, so contained in here is multiplying both sides by 4.9, then taking the inverse sine of both sides. And you'll get that angle D measures approximately 47 degrees. And you can carefully put this into your calculator just as it's written. You might need 2 sets of brackets to do it in order to separate this group while keeping the fraction involved in the inverse sine function. Okay. Anyway, we got that the angle D is 47 degrees. How am I going to solve for angle F?
You do the same just with sin D over D.
Yeah, good. I could do the exact same. There's a faster way.
Oh.
I have
Oh,
two
yeah,
of
all the,
I have two of my three angles.
do that too.
Sum of interior angles equals 180 degrees. So, angle F is 180, and I've been working in red, so I'm going to keep doing that. Angle F equals 180 minus 47 minus 64, which tells us that angle F is 69 degrees. Because I was asked to solve the triangle, I'm going to box all the information that I found out. 3 pieces of new information, 3 pieces of information already given. I'm done. I've solved this triangle. I could fill in the rest of my diagram, which I just need to add my last angle. And we're done. Okay? Not too hard. It's you use it when you can't use anything else. Okay? When you're in a side angle side situation. And tomorrow we'll learn what to do if you're in a side situation. And actually, if you're in a side situation, you already have side, then the only thing missing in this equation would be the angle. You can use this equation again, but we're going to rearrange it to make it a little bit easier. Okay? Your practice problems come from page 373. Page 373.
There are some key concepts.
Yeah, we can write those in. That's right. Page 373, numbers 1, 3AD, 6, 7, and 11. And those key concepts, let's just talk about them. In an acute triangle ABC, the cosine law states that those are the 3 statements that you did at the beginning, okay? A squared equals B squared plus C squared minus 2BC times the cosine of A. Okay, it's just that written 3 different ways. For A squared, then for B squared, then for C squared. That's all it's asking you to do in those 3 bullets. And the end, it says the cosine law can be used to find a missing side length, if the other 2 sides and their contained angle. So you can find a missing side if the other 2 sides and their contained angle is known. What does that mean? It means we know this guy, and the contained angle. That allows us to solve for this 3rd side. Okay? Side, angle, side. All right, practice problems. Enjoy.